All right, so it is exactly 4:30, so we will be punctual. And I want to welcome you all here today. I'm glad that we are all science lovers and we have come to this event. So without further ado, let's start. All right, so Speedy Science 2022, this is our event hosted by Phi Tau Sigma, the University of Minnesota chapter, and we are the Honor Society of Food Science and Technology. And you'll learn more about our wonderful organization in just a bit. So here's an outline of what tonight is going to look like. We are going to talk about Phi Tau Sigma, which again, great organization, and that will be presented by Leslie, who is our wonderful president. We will also talk about who we are, which are the board members. Also, this is the first time we will thank our sponsors and judges tonight, but it will not be the last time. We will do it many times throughout because they made this event possible. And then we'll move on to our presentations. And between each presentation, we'll have trivia. And actually, you'll be able to win prizes. And then lastly, of course, we have to announce our winners. First, it will be trivia, and then we get to hear the Speedy Science winners. So now I will let Leslie talk about Phi Tau Sigma, who we are, why we're unique, and why you should join us.
Thanks, Sarah. Once again, I want to welcome everybody, participants, audience members, and judges for coming to this event. We really appreciate you and your support of our chapter, Phi Tau Sigma. Just kind of going over kind of why our specific chapter is a unique chapter of Phi Tau Sigma. We do have a lot of collaboration with a lot of different universities. Currently, the University of Minnesota is working with NDSU, SDSU, and UW-Madison very closely to help kind of build at those universities to potentially have a chapter someday. And then also having some leadership opportunities with some other organizations outside of Phi Tau Sigma, including IFT, ADSA, ASABE, and COFE. We also have a lot of different student scholarships, and as you'll see in a minute, we get a lot of those scholarships at the national level. We also have the opportunity to participate in a lot of different competitions, such as the one you're at tonight. And then there's a lot of different award opportunities as well. So just to kind of recap, some of our recent student accomplishments that students at our chapter have received have included the past 3 years, we've had students win the Student Achievement Scholarship at the national level. In 2019, we also had a student win the Dr. Guy Livingston Scholarship. And we also had a student just this year win the Dr. Darrell and Mrs. Dawn Lund Student International Scholarship. And as a chapter, we've had some great accomplishments, including Outstanding Chapter of the Year in 2014 and 2021. And we've also received the Chapter of Excellence Award in 2019, 2020, and 2021 as well.
And with Leslie's help, I believe 2022 will come as well.
So in addition to all of those accolades that our chapter has been able to achieve, we also have a lot of different membership benefits just at the national level for all members. For students, there's the opportunity to apply for exclusive awards and scholarships for Phi Tau Sigma members. There's the opportunity to join in different board and committees, so we can become leaders at the national level and within different chapters. We get the opportunity, like I mentioned, to network, since we can have the opportunity to work with both industry members and academia. We really get to bridge everything between students and connecting them with industry members. There's also the opportunity for a lot of mentoring as well with that. Again, we get to compete with our peers and share our research, like with Speedy Science. At the national level, there's lightning talks, different poster competitions, as well as different oral competitions as well. You also get the opportunity to potentially be featured in the national newsletter for either just being a member or having your research spotlighted in the national newsletter. And then who doesn't want a little extra bling for graduation? We also give our student members honor cords and pins for graduation as well. If you have any questions about membership, how to become nominated to potentially become a member, or the requirements needed for that, feel free to reach out. My email is on the slide and I'd be happy to talk with you. Also, I just wanted to introduce my lovely officer team for this year. As I've already been introduced, I'm the president. Our vice president, unfortunately, she wasn't able to make it tonight. She's Gretchen. She just graduated with her master's in food science here from the U. Our lovely treasurer is Brigida. Our co-chair is our fearless past president, Sonali. Our wonderful secretary, who you heard so much from already, is Sarah. And then our social media chair, who you'll get to know a bit more through our trivia, is Priyanshi.
All right, thank you, Leslie. And I have to say, if I wasn't in Phi Tau Sigma already, I would join just for the extra bling. All right, so now we will let the Speedy Science competition begin. So to make this competition possible, we had many great sponsors, including a gold sponsor of Cargill. So thank you to them. Also, Purus was another wonderful sponsor, and we have at the silver level, we have Go Macro. So we'd like to just take a moment, give a shout out to all our sponsors. Like I said before, we will thank you numerous times throughout for your generosity, because you truly made this event possible so that we can all see what these presenters have to say and learn more about something they're so passionate about. And then also a big thank you to our judges who read through numerous abstracts, have gone to practice sessions, and have dealt with a lot of emails that I've sent them. So thank you to Lauren Jackson from the FBA, Russell Cross from Texas A&M University, and Angela Bonema from Cargill. So thank you to all you judges. We will thank you at the end as well. And you have been wonderful, and we truly all appreciate the work you've done. All right. So at this point, I will take a breath and let you log into our trivia platform, which is www.kahoot.it. And you can do this on your laptop or phone. And once you pull up the website, you'll be able to enter the game pin, which Priyanshi will be lovely enough to share with you in the chat. And once you get the pin, you can log on to, you can log into the app, and it will ask you for a name. You can use your nickname or your actual name. If you want to be Food Science Trivia God, that is up to you. I will not stop your creativity. And then, so after the presentations, the trivia will start, and you'll see the questions coming up on your phone as well as on the Zoom screen. And then you can answer those if you think you have the answer, or if you know you have the answer. And then the faster that you answer, you actually get more points. And the scores are totaled throughout this entire event. And at the end, our top 2 point earners get our special trivia prizes. So I will say I would participate in trivia. Plus, I've heard wonderful people wrote the questions. So just putting it out there. All right, so did everyone see the game pin in the chat? All right. And then you'll also have time throughout the event to log on to trivia as well if you don't get time to do it now. But so then now that we have trivia down and everyone is aware of that, we will move on and go into best practices. So as with any Zoom call, if we've experienced, there are some things that we do to make it go well and show our manners and support. So unless you're presenting, keep yourself muted. If you are the presenter, please unmute yourself because it's going to be an awkward 3 minutes of silence. We also encourage question and answers. We will let the judges ask questions first. And then once they have finished, anyone within the audience is allowed to unmute themselves and they can ask their question personally, but you can also type it in the chat and the participant, and we'll read it out to the participant. If at the end you don't get your question answered, if we run out of time, you can also send that to us or the participant, and we will hopefully get an answer back to you. And lastly, show your support for your peers. They were brave enough to do this, and without them doing this, you wouldn't get to hear about their wonderful projects, and we wouldn't get to know even more about food science. So once again, one last overview of what this event is going to look like. It'll be a presentation, which of course, 3 minutes, followed by a short question and answer session, where once again, remember, judges go first, and then you can have your turn. And then we move into trivia while the judges are scoring. And then we have our next presentation after the trivia. And the whole cycle begins again. All right, so I would now like to introduce our first presenter, which is Amino. And the title of his presentation is AG Biomass Cellulose, a valuable source to develop biodegradable plastics. So, Amino, if you want to start sharing your screen now, you'll have 3 minutes. As soon as you start talking, we'll begin recording you.
Thank you, Sarah, for your nice introduction. Can everyone see my screen now?
Yeah, we can see your screen.
Good afternoon, everyone. I am pleased to have this opportunity to present within 3 minutes on Speedy Science Competition 2022. Plastics are versatile and cost-effective materials with a wide range of functionalities. However, due to lack of biodegradability, environmental and health concerns regarding plastic disposal are immense. Plastic takes more than 700 years to break down, and only 9% actually get recycled, unfortunately. No matter how much we use the recycle bin, the rest ends up in the landfills and oceans and killing over more than 1 million of marine animals each year. In addition to the environmental problem, the leaching of chemicals such as polypropylene from the plastic and transferred to human and wildlife induce harmful and carcinogenic health impact. So what are the solutions to this problem? Toward this end, cellulose from sustainable and abundant agriculture biomass stand out as a viable alternative to develop biodegradable plastics. The high percentage of cellulose in agriculture biomass is comparable to woods that indeed can save more trees and prevent global warming. In this regard, it is more prudent to extract cellulose from agriculture biomass instead of cutting down trees. And cellulose is extracted from agriculture biomass by using a combination of alkaline and bleaching treatment. Due to its long structure with the stiff molecule, cellulose is insoluble in water that limits its overall utility. That's why zinc chloride is used to solubilize the cellulose, and later calcium chloride is added to further strengthening the zinc cellulose chains towards film development. And the films developed by this protocol are biodegradable, transparent, as well as have high tensile strength that we can see in the picture. And in terms of biodegradability, in the graph, we can see that the films completely biodegrade within 28 to 35 days. And more surprisingly, in the bar graph, we can see that the cellulose-based film have high tensile strength even compared to commercial polythene. Overall, cellulose-based film from sustainable agricultural biomass can not only address the plastic issue, but it can provide value addition to farmer as well as to agricultural industries. Thank you. I'm sorry that I forget to turn on the video.
Oh, that's
I totally
okay.
forget that the video was turned off. Sorry for that. Anyone have any question?
Oh, you took over my job, but yes, thank you for your presentation, and we'll move on to questions. So, do any of our judges have a question?
I have a question. Hi, this is Angie. Have you investigated the impacts of a product being in these films during shelf life? Is there any potential interaction with a low pH semi-solid or beverage or even an oil-containing product over time?
Okay. Oh, that's a good question, Angela. But till now, actually, we are not working with any product right now because we are focusing on right now on developing film with more high tensile strength. But last time, we are thinking of trying with the fruit, especially to use the cellulose-based film for the fruit and see whether they can affect the gas permeability, and we can store the tropical fruit like mango for longer time. But still, we didn't complete it yet, so I don't know exactly that.
Great, thanks.
All right, do we have any other questions from judges or audience members? All right. Well, I want to thank Amino once again. That was very good. And I have to say, I think this will actually be really beneficial to the world, just with biodegradable plastics. So thank you for giving this talk, and I look forward to see what this will lead to in the future.
Thank you.
Yeah.
Better.
So I'll clap you. All right. So now we will move on to trivia hosted by our wonderful social media chair, Priyanshi.
Thank you so much, Sarah, for that introduction. I'll be hosting the trivia to test your knowledge in food science. Just log on to www.kahoot.it. The pin is in the chat box and it's also on the screen. You can also scan the QR code to enter the game, and please enter your name. I'll wait for another minute to people to join. All right, let's start. You don't want to miss this game because we have exciting prizes for the winners. What two monosaccharides are linked by a glycosidic bond to form the most prevalent disaccharide in milk? Is it galactose and galactose, B, glucose and fructose, C, glucose and galactose, or D, glucose and glucose? Ten seconds to go. And the time is up. So the correct answer is glucose and galactose, which was answered by 9 people, which actually forms to make lactose, which is the most prevalent sugar. Option B forms sucrose, which is the kitchen sugar, while option D, glucose and glucose combine to form maltose. Next question. Somebody with the name green cheese is on the lead. I like the name. Question second. In which year was Phi Tau Sigma found? That's a pretty tough question because I don't think anybody's good with remembering years. Is it 1968, 1953, or 1980? Do not skip the question and try to answer it fast as it will increase your points. The correct answer is 1953, which was answered by 8 people. That's a good number. Phi Tau Sigma is a society which works towards appreciating the students and professionals in the food science and technology. Green cheese is still leading. I would like to know who came up with this name. Next question. Iodine tests are used to detect what in foods? Is it fat? Is it amylopectin in starch? Or is it amylose in starch? Or is it fiber? Ten seconds to go. And time's up. The correct answer is amylose in starch because it has a helical structure which combines with iodine molecules to yield a blue-black color. And the correct answer is given by 10 people. Doc Z has the highest answer streak of 3, but somebody who's passionate is leading the scoreboard, which makes sense. Moving on to the next question. Which of the following is not a product resulting from wet milling process of corn? Is it corn flour, corn oil, corn starch, or corn gluten? "13 seconds to go. All right, the correct answer is corn flour, which is answered only by 3 people. And the scoreboard is still led by passionate. And I think it's time that we move on to our next presenter. So over to you, Sarah.
All right, so now we will move on to the next presentation. So let me
Sarah,
start. Yes.
so according to my Qualtrics, I only have received 2 of the scores.
Okay. Just a moment.
So we have to remind the judges.
So judges, as a reminder, while we're playing the trivia, make sure you submit the score, and make sure after you enter in all of the element, make sure you click the link to submit the answer. Thank you.
Sarah, did you receive my scores?
Let me check, and I did actually just send you the link again as well.
Oh, I just got it.
You
Okay,
got my scores?
Yep, I got it, all three of you. Thank you.
perfect. Thank you. All right, it wouldn't be a Zoom call without some technical difficulties. All right. So now we will move on to our second presenter, which is Baswati. Am I saying your name correctly?
Yes, that's correct.
Oh, thank goodness. I can barely say my own name. And the title of Baswati's presentation is Let's Win the War Against Listeria and Ensure Food Safety. So, Baswati, if you want to start sharing your screen, you will have 3 minutes. And once you are complete, question and answer. So, whenever you start talking will be when we start the timer.
Yep. Thank you for the nice introduction. Is my screen visible?
It is.
Okay. Okay. Microbes are everywhere around us. Do you know that half of the oxygen in the atmosphere is actually produced by microbes? But not all of them are good. This is the reason in today's COVID-19 crisis, we are all having to wear a mask and carry a bottle of hand sanitizer in our pockets. Unlike coronavirus, which is a virus, I am obsessed with bacteria. And to be more precise, I am obsessed with bad or pathogenic bacteria. We wash our hands with soap, clean our floors with disinfectants because we are in constant fear of bacterial infections. And such fear is reasonable because bad bacteria like Listeria monocytogenes exist in this world. Listeria causes a disease called listeriosis, which is the third leading cause of death due to foodborne illnesses. Each year, 1,600 people get listeriosis and 260 people die. This bacteria very cunningly trespasses into the food industries through raw materials and employees, and thereafter they sit on the floor surfaces very stubbornly. Food industries, they clean their floors after every 3 days, yet we still see cases of listeriosis. My research focuses on understanding, can listeria still survive on the floor surfaces despite these food industries cleaning their floors with very rigorous floor cleaning protocols? Spillage of food particles can occur here and there in food industries, and Listeria takes advantage of such free food, feed on them, and grow in numbers. Further, if they find the area too cozy because of ample amount of nutrients and the floors have a very good roughness for them to grip on, it's like similar to how we slip on ice, but we can walk on cemented floors. So then Listeria communicate with one another through small molecules and build the house in the area. The houses they build are made out of a thick, sticky substance and is called biofilm. Biofilm protects the bacteria from the external environment. So when cleaning chemicals are introduced, it cannot penetrate through the biofilm layer, and the bacteria inside are all alive, healthy, and ready to cause an outbreak by cross-contaminating into the food products. Through my research, I found out that 3 days, not 3 days, not 2 days, but cleaning of the industrial floors on a daily basis for both new and used floors that is up to 15 years used can, like if they are cleaned on a daily basis, then Listeria can be effectively removed or controlled. Initially, we thought that on used floors, like due to frictional wear and tear, there will be a smoother surface and Listeria won't be able to form biofilms effectively. But this was not the case. However, like cleaning of floors on a daily basis is expensive. So I hope that by targeting the molecules through which Listeria communicate with one another, we can stop biofilm formation by Listeria. And this way, the chemicals will be able to effectively reach Listeria and kill them and eventually stop the outbreak of listeriosis. Thank you.
All right, thank you, Baswati. I have a new fear of Listeria, but I have hope that your research will help.
Thank you.
And then it looks like you were at 3 minutes and 4 seconds. So good job. You went over time less than I did when I did this. So now we will open the floor for question and answers.
Yeah, I have a quick question. How will your cleaner actually cut through the film to get to the communication molecules?
Hello, am I audible?
Yes.
So like I don't have to cut through the film. Firstly, like that's a very good question. Like how Listeria forms biofilm is through like secreting autoinduction molecules. So like if there are enough of Listeria cells present in a locality and when they secrete autoinduction molecules, then the genes that actually express for biofilm formation are biofilm formation is instigated. So like what I'm targeting is I'll target the autoinduction molecules that actually helps in expressing biofilm formation. So even before biofilm formation, I'll be targeting these molecules so that they won't be able to form biofilms and the cleaning chemicals can easily access the bacteria and eliminate them. I hope I answered your question.
You did. Very good answer. Thank you.
Thank you.
All right, any additional questions? And remember, you can always type it in the chat as well.
Hi, I have a quick question. Great job, by the way. So I just wanted to make sure I understood correctly. So it actually takes a lot more work to upkeep a used floor over time for cleaning?
Like, can you repeat the question?
Yeah, I just wanted to clarify. So it actually takes more rigorous cleaning to keep a used floor clean?
No, it doesn't actually. Like when I compared the old floor, which was like 15-year-old with a new one, which was not used at all, and I compared the roughness between the floors, when I saw that there was only a 0.83 average roughness difference between these floors, even though the old one is used for 15 years. So and this roughness difference is not effective enough to let Listeria grow biofilms in a much higher difference on both the floors.
Thank you. Thanks for the clarification.
I would like to add to the answer. So so because there is no difference between biofilm formation on both the floor surfaces despite being used for 15 years. So it's not that you will have to employ more rigorous cleaning. You will have to employ the same amount of cleaning on both the floor surfaces because same amount of biofilm formation is there. Thank you.
Hi, Baswati, this is Claire. Kind of as a follow-up question to that, did you look at any other characteristics between the used and the new floor that might impact Listeria harborage? I'm thinking of kind of absorption of moisture or holding moisture.
That's a good question. I am planning to look at hydrophobicity and zeta potential, which can also have an impact on biofilm formation of Listeria. So apart from that, I haven't apart from the floor roughness, I haven't yet progressed much. So thank you.
Okay, thank you.
All right, and those are wonderful questions, but for the sake of time, we do have to move on to trivia. But if you do have additional questions that you want answered, you can email it to one of the board members or put it in the chat and we will get it to Baswati at a later time. So thank you again, Baswati. I'll give you a clap as well. Great job. And now if Priyanshi wants to take over with trivia again and we can start the epic battle.
All right, back to our trivia. If anybody still wants to join the game, the pin is in the chat box and also on the screen at the bottom right corner. And I'm going to start the next question. Which is not one of the big 9 allergens in food? Is it soy, peanut, milk, or sorghum? Allergens cause allergenic reactions in a body, and recently there have been big 8, but one has been added to the list, and let's see what it is. I mean, let's see what not is. Sorry. The correct answer is sorghum, but the big 9 allergens are milk, eggs, peanuts, tree nuts, wheat, soy, crustacean, shellfish, fish, and sesame is the latest that has been added to the list, which is answered almost correctly by almost everybody. And a passionate person is still leading the scoreboard. Next question. Unless denatured by heat, this protein is soluble even at isoelectric point. Is it casein, or is it whey protein, or is it pea, or is it soy protein? Ten seconds to go for the right answer. All right, the right answer is whey protein, which is answered by only 5 people. Whey is the most soluble protein, even at the isoelectric point due to its high hydrophilicity, and it can be soluble over a wide range of pH from 2 to 9, which makes it an important source in beverage applications. And Passionate is still on the lead, and it's time for our next presenter. Thank you.
All right, so moving on to the next presenter after that thrilling round of trivia. So now we go on to Louis. Is that correct?
Yeah, I think
Okay.
so. Let me try to share my screen firstly.
Oh, yep, and then I will just introduce. Your title is Enhancing the Foaming Capacity of the P Biofilm fraction by physical treatments. So once again, 3 minutes. And once you begin talking, we'll start. Oh, don't forget to turn on your video, by the way.
Just wait. I start video, and share the screen. Can everyone see my screen?
Yes, perfect. So then once you start your presentation, we'll start the timer.
Okay. As we know, exploring protein sources to alternative animal proteins has been at the forefront of food ingredients innovations. So in recent years, pea protein isolate has received increasing attention because of the competitive prices and valuable functionalities. With respect to its functional properties, foaming capacity is one of the most important functionalities, which is closely related to its application in food industry. Globulin is the major storage protein in pea. It can be divided into 2 fractions according to the sedimentation coefficients. They are Riesling with a trimer structure and Legumin with a hexamer structure. According to one of my previous studies, compared to the total globulin in the Legumin, the foaming capacity of Riesling was outstanding because of the high solubility and less rigid structure. However, despite this, as a plant protein, the foaming capacity of pea Riesling still compares unfavorably with some animal proteins such as egg, white, and casein. Therefore, the aim of this study is to physically modify pea Riesling by pH shifting, heating, and ultrasound treatment in order to improve the foaming capacity. So, following is the result. I firstly did the foaming test, and I was so excited to find that compared to pea Riesling control, all of these individual physical treatments improve the foaming capacity, especially heating treated samples. its foaming capacity was even more superior than that of egg white and casein. To find out the principle of this improvement, I did the HPLC SEC mouse test next. It was clear to see from that chart that both pH shifting and heating treatments created more soluble protein aggregates. But how did these aggregates improve the foaming capacity? I did a dilatational rheology test. Firstly, a droplet of protein solution is formed in air. The protein from a box solution diffused to the air-water interface and form a protein film at the interface. During the measurement, the interface area of that droplet is changed sinusoidally in 1.5 hours. The dilatational elasticity of the protein film can be calculated according to the actively changed surface area and passively changed interfacial tension. So we can show this figure. From the result, we can clearly see that the dilatational elasticity of heating and pH shifting treated samples are higher. So that means protein with more aggregates can form a more elastic film, especially a heating treated sample. So that may be the reason why more aggregates improve the foaming capacity. Okay, that's all of my sharing today. Thank you.
All right, good job. So I will open it up to, well, first I want to say great presentation. I forgot to say that, but it was. So I want to open up the floor to questions and answers, first from judges and then from audience members.
Yeah. I have a question regarding enhancements. Have you considered further hydrolysis to be able to increase the foaming capacity as well as the stability? Or is this being done currently with some of the processes that you're already doing, the ultrasound?
You mean the foaming stability?
Yes. As there, I asked because there's a few proteins on the market that have that are quite hydrolyzed, and they have quite some great functionality in that sense.
Yes, I actually concerned about the foaming stability, and I really did the experiment as well as the foaming capacity, but unfortunately I didn't find the significant improvement from the pH shifting and heating treated samples with the p-vaseline control samples. So I didn't post the result here. And I think the most significant result, the improvement, is the foaming capacity. So that's why my topic is the capacity.
Oh, and it looks like we have a question in the chat from Sonali. She asks, "What did you notice any changes in temperature during the ultrasound treatment?"
Yes, I think that's a really good question. It seems like you used to use the ultrasound treatments before, because I put the beaker in ice so that I controlled the temperature to no more than 30 degrees to prevent heating. I hope I answered your question.
And I guess I have a question. What kind of applications do you see this being used in? The pea protein.
I'm sorry, what kind of application?
Yeah, so what type of products do you see this being used in?
Oh, I didn't use the commercial pea protein. I just extracted the protein by myself using the isoelectric point precipitation method. Because I found that the functional properties of the proteins I extracted by myself is much better than that of commercial proteins.
Oh, thank you.
Yep.
Okay, and then I think if we have additional questions, once again, you can put it in the chat, but we will move on to trivia. So Priyanshi, back to you. Oh, and thank you again.
All right, back to the trivia. Next question. Why would you want to hydrogenate an oil? A, to decrease its oxidative stability. B, to improve its health properties. C, to increase the melting point. Or D, to make it more liquid. Once again, I would like to remind you to use the pin in chat or at the bottom right corner of the screen to join the game. And you cannot join in the middle of a question, but certainly for the next question. And the right answer is to increase the melting point, because the unsaturated fatty acid gets converted into a saturated one by hydrogenation, which increases its melting point and converts it into a more solid form, which is less prone to oxidation, which was answered correctly by 8 people. Next question. Passionate is still on the lead. This process was developed by Nicholas Eppert. Is it salting, canning, dehydration, or freezing? $15 to go. And the correct answer is canning, which is given by 11 people. Nicholas Eppert coined the term canning, which is also known as Eppertization, which involves hermetically sealing containers to preserve food for longer time periods, which involves application of high heat. And Passionate is still leading. Let's see how the game proceeds after the next presentation. Thank you.
All right, well, Passionate appears to be very passionate about trivia. So, congrats to you. And we will move on to, after that smooth transition by me, we will move on to our next presenter, who is Holly Husband, with the presentation, Legumes of the Future, Enhancing Functionality and Nutrition of Pea Protein. So the protein saga continues.
It really does. Thank you. Let's share. All right. Can people see my screen?
Yes.
Awesome.
Oh, and then once again, to state the rule again, you have 3 minutes. We'll start timing once you begin talking.
Thank you. All right, hello everyone, and thank you for being here today. As Sarah said, my name is Holly. I'm a master's student under Dr. Ishmael at the University of Minnesota. So let's begin. For anyone paying attention to our food scene lately, you'll notice that plant-based offerings have exploded in many product categories, including dairy and meat analogs as shown here. If you've tried these, you might be surprised by how similar they are to their animal-based counterparts. That similarity is in part due to soy protein, which is the main food ingredient in both of these products. Soy protein historically has dominated this sector as it is a highly functional and nutritious ingredient. However, over 90% of the soy in the US is GMO, and it is a big 8 allergen. This presents an excellent opportunity for pea protein, as it is currently non-allergenic and non-GMO. Pea protein, like soy, is largely composed of 7S visicolin and 11S legumin as its main storage proteins. The ratio of 7S to 11S is critical to nutritional quality and protein functionality. Soy protein has about twice the amount of 11S than 7S, while pea protein can have 5 times less 11S than 7S protein. This makes pea protein less nutritious and functional than soy, which has limited its application and acceptance. Therefore, the idea behind my research is if we can change the ratio of 11S to 7S within pea protein, we can improve its functionality and nutritional quality. To investigate, we developed an extraction method to isolate the 7S and 11S from pea flour based on manipulation of NaCl, temperature, and pH. To validate this method, we used SDS page and anion exchange chromatography. These techniques help us qualitatively determine the type of proteins in our samples. The results of both of these techniques showed that our 7S fraction retained the Vislin subunits found in regular pea protein isolate, which I have framed here in these purple boxes, whereas the 11S fraction retained the legumin subunits, which are framed in these red boxes here. These results confirmed that we were isolating the protein components of interest for each fraction. Next, I will be testing 6 different ratios of 11S and 7S, shown quite crudely here by the varying levels of purple and red in each of these test tube icons. I will then evaluate the samples to determine which ratio produces the desired functionality and nutritional quality of pea protein isolate. Lastly, this study will provide data that can be utilized for targeted breeding efforts for high-quality pea protein ingredients to enhance its applicability to the food system. To illustrate this, I modified this cartoon of the Jetsons here to include this enhanced pea, both as an homage to my mom who grew up watching this cartoon and in an attempt to make my work resonate with her a little bit more, as she likes to often remind me she's not a food scientist. With that, I want to thank you for all of your attention, and it's a pleasure to share my work with you.
Okay, thank you, Holly. And I don't mean to hate on your mom, but the Flintstones is much better. So
I won't tell her you said that.
thank you.
Yes.
But I will now open the floor to questions and answers. And once again, good job. Oh, and you got exactly 3 minutes.
Woo!
All right. Do you have any questions from judges?
Yes, I have a question. Holly, first, you did a really nice job on your presentation. I have actually 2 questions for you. Okay, the first one has to do with your mention of soy being an allergen and pea protein not being one. And right now, pea protein is not one of the priority allergens. But since people are going to be consuming more pea protein in their diet, do you anticipate, pea becoming a priority allergen? Because as you consume more pea, it's very similar in a lot of ways to soy because it's a legume. So what are your thoughts on that?
Yes, I definitely agree with you. We've kind of seen that trend, whereas people start to consume more of a certain type of ingredient, that's when that allergenicity develops. So with pea protein, yeah, being as like an underutilized source of protein right now, that allergenicity hasn't necessarily developed in humans. I would guess that would be the case though, like as pea protein would become a more common source that we would start to develop those allergens. However, there would need to be work done, like which of the proteins would have that allergenicity. For example, I can't remember which protein in soy is responsible for allergenicity, but that work could also be done for pea protein, and potentially we can modify the pea protein to maybe breed against the allergenicity or modify it somehow so it's less prevalent.
Great, that's a great answer. Thank you. Second question I have for you is, you were mentioning about the nutritional properties of pea protein. What is it about pea protein that makes it less nutritionally available than soy? Is it missing, some amino acids or essential amino acids? I'm just not sure.
Exactly. So soy protein has a more complete profile of amino acids compared to pea. So the protein digestibility of soy has been reported as like 0.9, I think, which is close to 1, which would be the perfect score. Pea is reported as like 0.8, I believe, in most studies, which just gives it a slightly lower nutritional value. But the hope is that, yes, like I mentioned with my work, as we modify that protein profile, we can perhaps enhance that protein digestibility score a little bit more to make it a little bit more comparable to soy.
Thank you.
Yes, thank you.
Okay, any Other questions from judges or audience members? Oh, and if that's it, then we will move on to trivia and let the judges score. So once again, Holly, great job.
Thank you.
And good question and answer session. And also I want to say, I'm glad to see all the support in the chat. There's lots of shout outs to our contestants. So good job to audience and the contestants.
All right. Let's see who can be passionate in the quiz. Moving on. What is the name of this fatty acid? That looks like a complex compound. Is it linoleic or linolenic? Or is it oleic or is it palmitic? Once again, use the code. Use the pin on the screen to log into the game. And the correct answer is linoleic, which was answered only by 2 people. Linoleic acid is a polyunsaturated fatty acid, which is found in plant oils like sunflower and safflower. The answer, which was B option that was answered by most people, is linolenic, which is also a polyunsaturated fatty acid, which is obtained from flax seeds, hemp, and chia. Next question. Green cheese. Again, a very smart name, which is almost to the top position. This is Oski the bear. It is a mascot of which university? This is a tricky question for people who don't know about mascots like me. Is it University of Minnesota, Kansas State, UC Berkeley, or Washington State University? It looks yellow. It could be of University of Minnesota. The correct answer is UC Berkeley, which was given by 10 people. Goldie Gopher is the mascot of University of Minnesota, and Willie the Wildcat is the mascot of Kansas State. And for Washington State, it is Pooch the Cougar. And the bear is actually signifies the California Bears, which is the mascot of UC Berkeley. So next question. Green cheese has taken the lead. That's a really cool name. I really want to know how you come up with that. Next question. Which of the following would increase the rate of Maillard reaction? Is it by adding lemon juice, or increasing the pH, decreasing the temperature, or adding water? Ten seconds to go. And the right answer is increasing the pH, which was answered by 8 people. Adding water does not increase the Maillard reaction. However, increasing the temperature and the pH influences Maillard reaction and strongly accelerates it. Green cheese is leading, and somebody named Charles has the highest streak answer of 5. All right, next question. Which of the following is an essential amino acid? Okay, the structure does not corresponds to that, but yes. Is it alanine, leucine, aspartic acid, or tyrosine? The correct answer is leucine. Alanine, aspartic acid, and tyrosine are non-essential amino acids, which are 11 in total, and there are 9 essential amino acids which are required by the human body. And with that, green cheese is in the lead, and it's time for our next presenter. Thank you.
All right, so currently shout out to green cheese right now. I basically did all my research on enzyme modified cheeses, so I'm very much a supporter of cheese. And with that, we move on to our final presenter, which is,
what's going on?
Our final presenter, which is,
Good.
and remember everyone, mute your mic when you're not presenting. So I will now introduce Radhika, and the title of her presentation is From a Food Scientist Toolbox, Developing Processing Strategies to Improve the Performance of Intermediate Wheatgrass. I'm not going to try to say that in food products. So Radhika, if you want to start sharing your screen and let us know how you actually say the scientific name of intermediate wheatgrass.
Thanks, Sarah. I can answer that question in my sleep now. Thyropinum intermedium. Okay.
And then once again, remember you have 3 minutes. We start the time once you start presenting. And just as a general shout out to the judges, always remember to hit submit. I forget that as well with questionnaires I make.
So hopefully you can see my screen and my video and hear me okay.
You are good to go.
Awesome, thank you. So today I take great pleasure in introducing you all to a novel perennial grain crop called intermediate wheatgrass, popularly known by its trade name Kernza. So I bet you're wondering what's so special about this new crop? How does this new perennial Kernza differ from our good old friend wheat? The answer lies in Kernza's extensive root systems as shown in the figure to the left. In contrast to wheat, which is an annual crop that requires tilling and replanting each year, Kernza, on the other hand, does not need replanting because its massive root systems remain in the soil for many, many years. These long roots help prevent soil and water erosion and act as a channel through which carbon dioxide from the atmosphere is stored back into the soil. So clearly, Kernza has some great environmental benefits. But how do we commercialize this new grain and use it in food products? This is where my food science research comes in. As you can tell, Kernza has a smaller seed size, which means more bran and less endosperm. So one of the functional challenges associated with Kernza flour is its high fiber content from the bran. This fiber competes with gluten-forming proteins for water and hinders the formation of a strong protein network. So how can we reduce this interference? This can be done through a process called tempering that I will be optimizing for Kernza. Tempering is a pre-treatment step that involves adding moisture and incubating the grains at certain time and temperature conditions, followed by milling and then separating the bran to get high-quality refined flour. Data gathered from my experiment showed that tempered refined flours form stronger gluten networks, resulting in more stable dough systems as seen in the dough rheology tests. After having developing efficient refining techniques, we are now left with huge amounts of Kernza bran as a byproduct. Is there a way to repurpose this nutrient-dense bran? I say hell yeah. And this is possible through steam explosion, which involves treating bran with high-pressure saturated steam for short times. This can reduce the activity of problematic enzymes in bran and potentially prolong its shelf life, therefore making it easier for you to add Kernza bran in your favorite baking recipes. By optimizing processing techniques such as tempering and developing tailored formulation strategies such as steam explosion, we can expand the food applications for Kernza. And lastly, if you're still wondering why we need to promote perennial crops like Kernza, well, think about it. By 2050, we'll have 10 billion mouths to feed, but the amount of land, water, and natural resources on Earth are limited. Thus, we need crops like Kernza that can sustainably feed the world without destroying the planet. And that is why I believe that the future of agriculture is perennial. Thank you.
All right, thank you. That was very good. And I believe that is the only presentation where we had cursing, and I support that. And I will also say I'm excited to see what brand new applications you have for your research. So that's my dad joke for the event. But now we'll move on to question and answer. So I will pass it off to the judges if they have any questions first.
A quick question. Very good job, by the way. How is the tempering actually done? What are the temperature ranges that you're using in your tempering process?
Thank you so much for your question. So for tempering, we're doing a little above room temperature. So the first condition is room temperature, the second is 30 degrees, and the third is 45 degrees. We didn't want to go beyond 50 degrees so as to not denature the gluten-forming proteins in the grain.
Okay, good answer. Last question, are you controlling the humidity during these processes of tempering?
Yes, my animated cartoon diagram didn't have the details, but we are going to keep it, we are keeping it at 50% relative humidity to make sure that it's in a controlled environment.
Okay, great, appreciate it.
All right, do we have any other questions? Also, remember, you can always utilize the chat. All right. Well, then with that, I'd like to thank Radhika for your wonderful presentation and my last round of applause. So we will once again move on to our final round of trivia, so we get to see who the winners are going to be. And during this time, once again, judges will be scoring, we'll be adding up the totals, and after this, we'll be working on pronouncing our winners. So stay tuned, everyone. And now I pass it off to Priyanshi for our last round of trivia.
All right, thank you, Sarah. Let's continue with the trivia. And here we go. What amino acids are combined to make an artificial sweetener? Is it tyrosine and alanine? Is it tyrosine and aspartic acid? Or is it phenylalanine and alanine? Or phenylalanine and aspartic acid? It sounds like a tongue twister. Alanine. Five more seconds to go. And the correct answer given by 8 people is phenylalanine and aspartic acid. They combine to form aspartame, which is a low-calorie sweetener, but it is 200 times sweeter than sugar and is used in beverages, chewing gums, and nutrition bars. Green cheese is on the lead. Next question. Which chocolate brand has the slogan, "The Great American Chocolate Bar"? Chocolate lovers must be knowing the answer to this, and let's see who gets it right. Is it Yorkie or Hershey or Wispa or Star Bar? All right, time's up. And the correct answer is Hershey, given by 11 people. And it has the tagline, "The Great American Chocolate Bar." Next question. Green cheese is still on the lead with a score of 10,396. Which of these is not a protein? Is it gluten, lecithin, soy-like hemoglobin, or casein? This one's an easy one. Five more seconds to go. And the right answer is lecithin. Wow, some people answered soy-like hemoglobin, which is surprising. Lecithin is actually a lipid in which one fatty acid is replaced by a phosphoric acid. It's also called phospholipid. And next question. Between what two temperatures does bacteria grow the most in? 0 to 32 degree Fahrenheit, 32 to 40 degree Fahrenheit, or 40 to 140 degree Fahrenheit, or is it 140 to 240 degree Fahrenheit? Don't forget that these temperatures are in Fahrenheit and not degree Celsius. And the correct answer given by 7 people is 40 to 140 degrees Fahrenheit, which is about 4 to 60 degrees Celsius, which is why bacteria are such a nuisance in our food. Green cheese is still on the lead. Next question. What does the L stand for in FDA's alert tool? Is it listen or leave or limit or look? Ten seconds to go. The right answer is look, which is only answered by 3 people. The FDA's alert is a program which identifies 5 key points that the industry and businesses can use to decrease the risks of intentional contamination of food products. It stands for assure, look, employs, reports, and threat. Green cheese is still on the lead. Next question. Which statement is true about lactase? When added to milk, it increases the sweetness of the milk, or does not affect the digestibility, most effective at low temperatures, or acts as lipase? Five seconds to go. The correct answer is A, increases the sweetness of milk, answered by 6 people only. And lactase acts on lactose to produce sweet flavor in milk. Green cheese is still on the lead. Woohoo! Which of the sweeteners below is the most intense? Is it advantame, or is it sucrose, or is it sucralose, or is it monk fruit? I'm going to help you out in this question, and because sucrose is not actually a sweetener, so you got 3 options left only. And the right answer is advantame, which was given by only 2 people, which is a very intense sweetener, which is 20,000 times sweeter than sucrose and 110 times sweeter than aspartame. Monk fruit is actually obtained from dried fruits of a plant, and it is 150 times sweeter than table sugar. And we have the lead taken by green cheese. And the last question, see whether who wins this. Pantothenic acid is also known as, is it vitamin B3, B5, B7, or B12? Ten seconds to go. And the correct answer is B5, which is pantothenic acid. Vitamin B3 is niacin, and B7 is biotin, and B12 is cyanocobalamin. The correct answer was given by 7 people. And drum rolls for the winner. So the 3rd position is taken by LC. second is by Charles, and the first is green cheese. Congratulations. So the first two winners will be given a $10 gift card. So I request Green Cheese and Charles to put their actual names and email addresses in the chat box so that we can get back to them. And thank you so much for joining and participating in this trivia and making it a fun quiz. Thank you.
All right, so that ends our trivia contest. Shout out to Green Cheese and Charles. So I think we all kind of want to know. Oh, we found out who Green Cheese was. So that is in the chat, and now we will move on. Oh, and thank you, Priyanshi, for hosting the wonderful trivia contest. I loved all the questions. And I have to admit, I wasn't quite sure about which of those was not a protein either. So there we go. Understandable how some people could miss it. So, and the winners are trivia winners, once again, Green Cheese and Charles, who have been kind enough to put their information in the chat, and they will get their gift cards soon. So very exciting. I will also clap you. All right, and then I will now pass it on to Brigitte, who will take over announcing the winners of our Speedy Science contest. So, Brigitte, I hand it off to you.
All right. Share. Whoops. Hang on.
We're going to do it all over again. It was such a good time.
Okay, there. All right, there, here. Slideshow. Play from current slide. All right, I got it. Okay. Can everyone see my screen?
Yep, we're good.
All right. So moving on to the most exciting part of this event, which is the winner. So the first place will receive $400 check, the second $200, and the third place $100. So let's go. For the third place winner, drum roll. It's Bashwari Chowdhury. Congratulations.
Yay!
All right. So yeah, congratulations, Bashwati. The next place, which is the second place, goes to Radhika Bharati. Congratulations. And the first place. The first place goes to Holly Husband.
Yay!
Congratulations, Holly. So yeah, with that, I think that's we reached the end of our event. So again, we would like to thank you for our gold sponsors, Cargill and Purus. Thank you very much for your generosity and your support. Thank you for our silver sponsors, Go Macro. Thank you for also your generosity and support. Thank you for all of the judges, Lauren, Angela, and Russell. Thank you for your time, your support, your effort, selecting abstracts and judging this competition. We also want to thank our participants who are here right now joining us in this event. And thank you for cheering your peers. And thank you for all of the finalists who are able to participate in virtually in person. And congratulations to all of the finalists and the winners. And I would also like to thank my Phi Tau Sigma team members for your support and help. With that, I also want to remind the finalists to tell the winners, especially, that we are going to reach out to you via email to get your address so that we can mail the checks, mail the certificate. And for all the finalists as well, all of you, 5 of you, we will also be waiving your nomination and membership fee for the first year if you wish to join Phi Tau Sigma.
And if I will also end it with, if anyone else wants to find out more about Phi Tau Sigma, feel free to reach out to anyone who's a board member, or maybe you have a friend who's in Phi Tau Sigma, and we can help you get more information. And Leslie just dropped her email in the chat. So, yeah.
Also, hang on.
Yes.
Also, for the finalist, we do have another opportunity for you. We already sent an email, so we'll be hosting some lightning talks from National Phi Tau Sigma, and we would be happy to have you in there. So please reach out to us if you're interested in that as well. And I think one of the person who organizes that, Claire, is also in the meeting. I think she'll be happy to have you guys over there. Thank you. And thank you everyone for coming through this wonderful competition.
And with that, we wish you all a wonderful evening, and we will see hopefully all of you back either as a participant or as an audience member for Speedy Science 2023. So, thank you and have a great night.
Thank you, Sarah.
Thank you.
Awesome. Thanks, everyone. Great work.
Thank you.
Bye all.